Hi children, welcome. Welcome to another chemistry class. Today we will be discussing the chapter Aldehydes, Ketones, Carboxylic acids. Organic chemistry chapter from the 12th standard portion. Can we start? Okay. First question. Reaction of a carbonyl compound with one of the following reagent involves nucleophilic addition followed by elimination of water. The reagent is. All of you know the reaction of carbonyl compounds with ammonia and derivatives is happening like this. It's reacting with ammonia, you get imine. Reacting with the substituted amine, you get substituted imine shifts base. Hydroxylamine, hydrazine, phenylhydrazine, 2,4-dinitrophenylhydrazine, 2,4-DNP, semi-carbazide. All these are functioning like this. There is the addition reaction followed by elimination, and that is the ammonia and derivatives interacting with the carbonyl compound, and the answer is no doubt option 4 is the correct answer. Option 4 is the correct answer. Hydrazine, you see acetone or any of the carbonyl compound. One of the carbonyl compound is taken and is reacting with the hydrazine. It is interacting. It is undergoing a nucleophilic addition reaction. It is undergoing a nucleophilic addition reaction. This is O minus and C plus, and this part of the molecule will be attaching one hydrogen comes here and NH2 group is connected here, and you get OH and NH2. Now there is elimination of water molecule, OH group, and H from the NH is gone, and you are getting hydrazone, C double bond N NH2. Hope you remember the reaction. C double bond O with H2NZ. Refer NCRT. It's going to remove like this. And you are getting the final product C double bond NZ. Z means different groups. There are 7 or 8 or 6 or 7 reactions are there. Ammonia with amine, hydroxylamine, hydrazine, phenylhydrazine, 2,4-DNP, semi-carbazide. All reactions you please verify. All fall under the same category where we find nucleophilic addition followed by elimination takes place, and fourth choice is the correct answer. Next question. Which one of the following esters hydrolyzed most easily under alkaline condition? Third one. Electron withdrawing group present. The C plus character will enhance and the hydrolysis will happen very easily. The presence of electron withdrawing group, nitro group is, I said option 3. Nitro group is electron withdrawing group. It reduces electron density, due to which the ester carbon atom becomes more electrophilic in nature. This carbon atom becomes more electrophilic in nature and easily attacked by the OH group. Okay. Next. The correct structure of product A, hydrogen gas 1 ATM palletized carbon ethanol. It is catalytic hydrogenation. Catalytic hydrogenation will affect over the double bond only. Answer is fourth choice. Keto group will not be reduced, while the alkene will be reduced to alkane. Fourth choice is the correct answer. That is catalytic hydrogenation. Next. Correct order of carboxylic acid strength. You know, acid strength is governed by electron withdrawing group. Here, oxygen in the ring can act as electron withdrawing group and is nearby position here, and that is most acidic. 2 is most acidic. And after 2 it will be 3, and the correct answer is fourth choice. 2 maximum, then 3, then 1. Here this acts as a electron withdrawing group, and that is nearby position. Here it is electron withdrawing group, far position. So this is maximum, then this. Here there is no oxygen, therefore minimum. Answer is fourth choice. 2 maximum, then 3, then 1. Next. Predict the correct intermediate and product in the following reaction. Correct intermediate and product in the following reaction. This is hydration of alkyne. Hydration of alkyne. You see, this is added with the water molecule. This is added with the water molecule, and OH minus will come on the Marconic of addition. OH minus will come on the middle carbon. And you are getting enol. Enol. So A is enol. A is enol. So first choice and third choice out. And which is rearranged to get acetone. Answer is fourth choice. Enol will undergo tautomerization. This OH group will come here. See, H atom will come here and double bond will come here. It's converted to acetone. Tautomerization. So the compound A intermediate obtained is vinyl alcohol. That is enol, propanol, which will tautomerize to give acetone. And the most important point, all of you know, if you start with the ethyne in this reaction, if you start with the ethyne, you will get aldehyde, ethanol. Any higher alkyne, you will get ketone. Okay. Next. Answer is fourth choice. Yeah, that's what happening. You see, water molecule is added over here. OH minus will come on this carbon. Hydrogen will come on this carbon. You get a enol, which tautomerizes. This hydrogen migrate to this position and double bond migrate to this position. You are getting acetone. So this is A and this is B. Next. Of the following, which is the product found when cyclohexanone undergo aldol condensation followed by heating? Cyclohexanone undergoing aldol condensation. So what is happening? Cyclohexanone. This is cyclohexanone, and this is alpha carbon, and this is also alpha carbon. So one of the hydrogen from here will be attacked by alkali, and you are going to get a carbanion. You are going to get a carbanion, and you get a minus here, and this will attack the next molecule of cyclohexanone. This will attack the next molecule of cyclohexanone, which is polarizing like this, and this is attacking over here. And the product obtained is there is a keto group and there is a cyclohexane ring with the OH group. This is the aldol. Aldol. This is functional group. This is alpha carbon. This is beta carbon. Beta hydroxy ketone. Which upon heating, this OH will be eliminated and hydrogen will be eliminated. You get a double bond over there. Unsaturated ketone. And the answer is option 2. Option 2 is the correct answer. Option 2 is the correct answer. If you analyze the mechanism concerned, you can understand option 2 is the correct answer. I will repeat. This is the cyclohexanone and this is alpha carbon atom and this is alpha hydrogen attacked by alkali. You get a carbanion. And now this carbanion attack on the carbonyl carbon of next molecule and you get aldol. And this aldol upon heating you get a double bond over here like that. Why the double bond is coming over there? Because of conjugated ketones are more stable, that's all. Always the aldol condensation product is conjugated aldehyde or ketone. Okay, next. Yeah, see that, whatever I have explained. Next. IUPAC name of the compound is, IUPAC name of the compound, you are starting from here. 1, 2, 3, 4, 5, 6. So it is 2-methyl 3-oxo. 2-methyl 3-oxo. It can be 3-oxo or 3-keto. There is no 2-methyl starting. So it can be 3-keto. 3-keto is there. So this is out. This is out. 3-keto, 2-methyl, hex, 4-enol. 5-enol is wrong. Answer is first choice. 3-keto, 2-methyl, hex, 4-enol. And I don't have to tell you, it's better to call it as oxo. It is better to call it as oxo, even though NCERT table permitted to be called it as keto and oxo. When the carbon in the chain, when you consider, no, it is better to consider it as oxo. But no choice is available, so I am picking the most appropriate choice. 3-keto, 2-methyl, hex, 4-enol. It would have been better if it is 3-oxo, 2-methyl, or rather it is 2-methyl, 3-oxo, hex, 4-enol. That would have been a correct representation. Okay, next. Anyway, here the most appropriate answer I am selecting option 1. Next one. Carboxylic acid have higher boiling point than aldehyde ketones due to fourth one, formation of intermolecular hydrogen bonding. Due to intermolecular hydrogen bonding, they have associating character. That's why. Next. This is how they associate, all of you have seen. The compound C4H8O found to react with NaOI produced by reacting Y with NaOH and yield a yellow precipitate with a characteristic smell. This is a question connected to iodoform test. Iodoform test. Iodoform test is given by those molecules except carboxylic acid and derivatives which contain methyl keto group or methyl carbinol group. So the molecule containing either methyl keto group, or methyl carbinol group respond to iodoform test. Remember, it should not be a carboxylic acid group coming. It can be aldehyde, ketone, secondary alcohols, etc. So only such molecule can respond to iodoform test. It is commented that there is yellow precipitate obtaining. Iodoform test is given only by one choice. See, here only you have methyl keto group. Methyl carbinol group. Here don't. No methyl carbinol group. This is phenol derivative. Here no methyl carbinol group. So methyl carbinol group we find only in one choice, and that is the answer. And what about Y? Y is same in the all cases. I2, I2, I2. So it is I2 with the NaOH, you are getting NaOI. There is no confusion in that. Next question. And this is what the reaction happening. This is what the reaction happening, interacting with the methyl carbinol group. See, this will break here and this is converted to iodoform, and this part of the molecule will be oxidized to acid salt. That is what happening. Next. An alkene A on reaction with the ozone and zinc gives propanol and ethanol. It is not ethanol. Ethanol cannot be. It is ethanol. Ethanol in equimolar ratio. Addition of HCl to alkene A gives B as major product. The structure of product B is. See, you are getting propanol and ethanol upon ozonolysis of alkene. What is that alkene? What is that alkene? You can easily find out. CH3, COCH3, this is propanol, and CH3, CHO, this is ethanol. And to identify which is the alkene concerned, very simple. You look at this area, just merge it. Remove oxygen and merge it with a double bond. You are going to get this molecule. CH3C, double bond, CH3 here, CH3, CH3. This upon ozonolysis, you will get propanone and ethanol. Now, this treated with HCl. This is, I think, what A is. This is A. This, when treated with HCl, there will be Markovnikov addition. Cl will come here and hydrogen will come here. And the product is CH3CCl, CH3, CH2, CH3. You get this? Which one is the answer? Option second choice. Option second choice. This is the correct answer. I think it is clear. Next one. Major product of the following reaction. First you will get ammonium salt. First you will get ammonium salt. So the first product obtained is ammonium salt, COONH4. COONH4. Upon heating, this will be converted to, by eliminating water molecule, you get amide, thalamide. You get thalamide. But it is commented to be strong heating. Upon strong heating, this NH2 with the H will be removed as ammonia and it will make a cyclic amide. And you get thalamide. This is thalamide. You get thalamide. First choice is the answer. So first you get a ammonium salt. From where water gone, you get amide. Upon strong heating, from that one ammonia molecule will be eliminated and the two group will merge to form a cyclic imide. Okay. Next. An alkene on ozonolysis gives methanol as one product. Here you don't get methanol. See, upon breaking here, this carbon will be converted to CHO. This carbon will be converted to CHO. You don't get methanol. Yes, this is the answer. Upon breaking here, this will be converted to formaldehyde. And that is the answer. Here, this and this are almost the same. Here you will get, it's breaking here. This is converted to CHO and this is converted to CH3CHO. So you get ethanol and cyclobenzene carbaldehyde. See, it is very easy to identify ozonolysis product. I think all of you know. Just break over the double bond and attach one oxygen to get the final product. Enough. Suppose you are given with ethene. How do you find the ozonolysis product? Just break it here, attach one oxygen here, and this is formaldehyde. This is formaldehyde. You will get two molecules of formaldehyde. Wherever you find a double bond, break it. Attach one oxygen each on both sides to identify the final product of ozonolysis in an alkene. A useful test for finding unsaturation, type of unsaturation, nature of unsaturation, position of unsaturation, number of unsaturation. Next. Reaction between acetone and methyl magnesium chloride followed by hydrolysis will give acetone, ketone with the Grignard reagent, tertiary butyl alcohol, formaldehyde with the Grignard reagent, you get primary alcohol. Any other aldehyde with the Grignard reagent, you get secondary alcohol. Ketone with the Grignard reagent, you get tertiary alcohol. Okay, next. Answer is option 2. And this is how the reaction taking place. This is plus, this is minus, this is minus, this is plus getting connected. You get an addition product and now this is removed. A hydrogen will come here to get tertiary butyl alcohol. Next. Identify the compound X. Identify the compound X. Benzyl chloride, option 2. See, suppose X is this one, you will get benzyl alcohol. This will result in the case benzyl alcohol. While here, this will give you benzaldehyde. Suppose this is the result. See, X can be this, this and this. Here, X is this because this only can give you this. Suppose X is this, you get benzyl alcohol, which is not in the question. Suppose X is this, you get benzoic acid. You get benzoic acid. So X is decided, X can be understood. Who is this? Looking at that final product, you can understand what is X. If you get benzyl chloride, you get benzyl alcohol. If you get benzyl chloride, you get benzaldehyde. If you get benzoyl trichloride, you get benzoic acid. See, all are possible because it is side chain chlorination. You can replace one hydrogen, CH2Cl. You can replace two hydrogen, CHCl2. You can replace all the three hydrogen, CCl3. CH2Cl, you get alcohol. CHCl2, you get aldehyde. CCl3, you get acid. Okay, next. IUPAC name of the molecule is simple, no? 1, 2, 3, 4, 5, 6. So it is 4 normal butyl. 1, 2, 3, 4. 4 normal butyl. 4 butyl. 4 butyl. 4 butyl. Option C. 4 butyl hexa 2,5-diene 1-all. Option C is correct. Next. Dibal H. Dibal H. Dibal H is a selective reducing agent. Selective reducing agent. CN will be reduced to. CN will be reduced to. It is hydrolyzing, no? If not hydrolyzing, you get this. Hydrolyzing means the answer is this. Option C. And Dibal H will reduce nitrile to CHO, aldehyde. Dibal H will reduce nitriles first to imine. Upon hydrolysis, you get aldehyde. While the double bond remain unaffected, the unsaturation part remain unaffected. Okay, next. The given molecule can be oxidized to this. Iodoform test, again iodoform test. This is methyl keto group. There is methyl group here and this is methyl keto group here, and if it reacts with NaOI, it is going to break here. This carbon will be converted to iodoform CHI3, and what is happening to this part? This part will be oxidized to acid group. You see, this part of the molecule will be converted to oxidized to acid group, and the methyl carbon will be converted to iodoform. Iodoform test. Okay, answer is option B. Not necessarily like this. It can be written I2 with alkali, or it can be X2 with alkali. It can be bleaching powder. Next. Acetic acid, bromine, red phosphorus. HVZ reaction. First reaction is HVZ reaction. In HVZ reaction, halogen will be coming on this carbon. So what is X? X is CH2BrCOOH. Now that is treated with the KCN. Bromine will go and cyanide will come. Bromine will go and cyanide will come. You get CH2CnCOOH. Now that upon hydrolysis, cyanide group will be hydrolyzed to COOH. So you get CH2COOH, and that is malonic acid. This compound is called malonic acid. Answer is option A. So first reaction, HBZ reaction. Bromine comes at alpha carbon, substituting a hydrogen. Now that bromine you are replacing with cyanide. And now that cyanide hydrolyzed to get carboxylic acid. And this molecule is propane dioic acid. Propane dioic acid, that is called malonic acid. The next homologue to oxalic acid. Next one. Smallest dissociation constant. Smallest dissociation constant means strong acid or weak acid? Smallest dissociation constant means strong acid or weak acid? Weak acid. Low Ka value means weak acid. So which is weak acid? Which is weak acid? Here you have fluorine, here you have bromine, here you have bromine. Nobody is available here. Answer is option A. This is electron withdrawing group, while this is electron donating group. Electron withdrawing group increases the acidic character. Electron donating group decreases the acidic character. So the answer is option A. So which will have high value of dissociation constant? No doubt. Here we have fluorine. The most electronegative fluorine when present, it is most acidic. Next, answer is option A here. Next, ammonia react with formaldehyde to give. Ammonia react with formaldehyde to give. All the above, you get urotropin. That is hexamethylene triamine. Urotropin. You get hexamethylene triamine. Not triamine, tetramine. Hexamethylene tetraamine. This is the structural entity. This is hexamethylene tetraamine. Used as a medicinal substance related to urinary diseases, urinary problems, under the name urotropin. Urotropin. Answer is option D. This is obtained when formaldehyde react with ammonia. Right. And the controlled nitration of this is producing RDX. Next. Keto-enol isomerism exhibited by molecule containing alpha hydrogen, aldehyde, ketone, nitro compounds, etc. containing alpha hydrogen can give you keto-enol isomerism. It is not option A because it is only one carbon. Answer is option B. Here you have alpha hydrogen and that will give you. It is not here. This is not as it is benzene ring. This is not as it is benzene ring. So in option A, no alpha carbon. Option C and D, there is alpha carbon but no alpha hydrogen. Alpha hydrogen present only in option B, ethanol, and that gives tautomerism. That is keto-enol isomerism. Next one. Acetophenone reduced to ethyl benzene by heating hydrazine KOH followed by the reaction is called Wolff-Kishner reduction. Carbonyl compounds reduced to alkane group. Reaction called Clemmensen reduction, Wolff-Kishner reduction. Clemmensen reduction you are using zinc amalgam with HCl, while hydrazine with ethylene glycol KOH, that is Wolff-Kishner reduction. Wolff-Kishner reduction. And this is what happening in Wolff-Kishner reduction. CO group will be converted to CH2 group. There is a choice Boviet-Blanc reduction, which is nothing but an ester reduced to primary alcohol using absolute alcohol and sodium. Using ethanol sodium, converting esters to primary alcohol. That is called a Boviet-Blanc reduction. Next, propan 2-ol on passing over heated copper. That also you have learned. Primary alcohol heating with the copper catalyst, you get aldehyde. Secondary alcohol heating with the copper catalyst, you get a ketone. While tertiary alcohol, you get a alkene. So the answer is ketone. Third choice. Propan 2-ol, a secondary alcohol heated with the copper catalyst, there will be dehydrogenation and you get a ketone. This is propan 2-ol. This is propan 2-ol. This hydrogen and the hydrogen from here, these two will be eliminated and it will be converted to propanol. It will be converted to propanol. Okay. Next. Strong heating, anhydrous calcium acetate gives. Calcium acetate on strong heating, you get acetone. You see, this is calcium acetate, CH3, CO, O, Ca, O, CO, CH3. This upon strong heating, what do you get? Calcium carbonate out. CaCO3 out. CaCO3 out. And what happens? This is interacting with the, this will get connected. You get CS3, COCS3. You get acetone. Option A. Answer is option A, acetone. Next one. Yes. Oil of bitter almonds. Oil of bitter almonds is benzaldehyde. Benzaldehyde is called oil of bitter almonds. Nitrobenzene called oil of myrrhabine. Sometimes you might have heard about. Benzaldehyde, colorless liquid with a characteristic almond-like odor. The primary component of bitter almond oil. That's why it is called the oil of bitter almonds. Next. Correct order of carbonyl activity. Correct order of carbonyl activity. See, aldehydes are more reactive than ketones. All of you know. Aldehydes are more reactive than ketones. This is a ketone. And aldehyde minimum. Wrong. This is aldehyde. Ketone. Option A is correct. Option A is correct. This is an aldehyde, ethanol, then acetone, and then this is a bigger ketone. Bigger ketone is less reactive due to steric factors. So the answer is first one. See, formaldehyde, most reactive, then other aldehyde, aliphatic aldehyde, then aromatic aldehyde, then ketones. It goes like that. The reason is electronic factors and steric reasons. Next, correct order of decreasing acid strength. Trichloroacetic acid, trifluoroacetic acid, trichloroacetic acid. CCl3, COOH. Trifluoroacetic acid, CF3, COOH. Acetic acid, CH3, COOH. And formic acid, HCOOH. So most acidic, what is doubt in this? This is most acidic. So B maximum. B maximum then A. B maximum then A. Answer is option C. B maximum trifluoro, then A trichloro, then formic acid, then acetic acid. See, formic acid is more acidic than acetic acid. Acetic acid is weaker. Once again, the logic is very simple. Electron withdrawing group increases the acidic character. CF3 is strongly electron withdrawing. So trifluoroacids are highly acidic in nature, having a low pKa value. Okay, next. When HCHO treated with the C6H5CHO in presence of the product is a product of, this is intramolecular Cannizzaro reaction. This is intramolecular Cannizzaro reaction in which formaldehyde will be oxidized. This will be oxidized to formic acid and this will be reduced to benzyl alcohol. So A is wrong. You don't get methanol. This can be, but this is wrong. Answer is option D. Answer is option D. This is reduced to benzyl alcohol and this is oxidized to formic acid. See, formaldehyde is a good reducing agent. Relatively, formaldehyde is a good reducing agent and itself it will undergo oxidation easily. So formaldehyde reduces benzaldehyde to benzyl alcohol. So this is what happening. This is what happened. HCHO act as a reducing agent and it reduces C6H5CHO to C6H5CH2OH and itself it is converted to HCOONA since it is alkaline medium. So this is oxidized and this is reduced. And this is intramolecular Cannizzaro reaction. Intramolecular Cannizzaro reaction. Next one. Sorry. I said intramolecular. It's cross Cannizzaro reaction. What is intramolecular? What is intramolecular? Suppose you are having a molecule like this, just imagine. CHO, when treated with an alkaline substance. You see, there are two CHO groups. One will be oxidized, one will be reduced. You get COO minus and CH2OH. This is called intramolecular Cannizzaro reaction. It was good that it came in my mouth, in the tongue, the name came, so that we have discussed that reaction also. Intramolecular Cannizzaro. That means a Cannizzaro reaction happening within the molecule. Here what is the reaction? Here what is the reaction? A cross Cannizzaro reaction. This is these two different aldehyde without alpha hydrogen interact. Formaldehyde, no alpha hydrogen. Benzaldehyde, no alpha hydrogen. So aldehydes without alpha hydrogen interact. And a usual simple Cannizzaro reaction is disproportionation reaction, but this is a redox reaction, where formaldehyde is oxidized to formic acid and benzaldehyde is reduced to benzyl alcohol. Answer is option D. Next one. In Cannizzaro reaction, the intermediate that will be best hydride donor. Intermediate that will be best hydride donor. See, hydride donor means H minus going, isn't it? Hydride donor means it should go as H minus. That means this will turn plus, and that is stabilized by electron donating groups. Option C is correct answer. Option C is correct answer. H minus removal is promoted by electron donating group. Yes, option C. Dioxoanion is a better hydride donor. Electron donating group at orthopara position further promote H transfer. So this H minus removal is promoted by a group like methoxy group. So the answer is option C. While this is electron withdrawing group. While that is electron withdrawing group. Right. Next one. That is HVZ reaction. HVZ reaction, iodine will come at alpha carbon. Iodine will come at alpha carbon. Option A, HVZ reaction. HVZ reaction, carboxylic acid interacting with red phosphorus and halogen. HVZ reaction. A halogen will come at alpha carbon. This is alpha carbon. This is not, this is wrong. Iodine will come at this carbon. Option A is correct. And that is HVZ reaction. And that was the last question from the concerned chapter, right? A very big chapter, a very important chapter from the organic chemistry when concerned. Lot of important reactions are coming, particularly like what do you call aldol condensation. Aldol condensation, different variety of aldol condensation, Cannizzaro reaction, acidic nature of carboxylic acids, etc. So many important reactions are commented in the concerned chapter. A very big chapter also. Right? So we will meet with another class with another set of questions in a different chapter. Okay? Bye. See you. Take care.